Hello and welcome to the fifth video in this series, Most Important Sets to Ace DILR in CAT 2021. Through this series of videos, what we have been predominantly doing is looking at various types of sets, including LR or DI, trying to find what is the logic of cracking such a set, and then going to the solution. But more importantly, what we are discussing also in these videos is whether or not to actually solve this set in the paper. What should be your decision-making criteria? What are the things that you need to know for each of these sets is what we are discussing. For this particular video, I have picked a set out of Games and Tournaments. You can also call it a league tournament or a round robin tournament, which is picked from one of our class worksheets itself. Those of you who are our classroom students would be able to recognize this set already. But what we are going to essentially look at is what is the reasoning that is required to be able to crack such kind of a set. This is a set based on points table. So this is the question in front of you. This is the setup. In a tennis tournament, 8 different players, namely A, B, C, D, E, F, G, and H, participated. Each player played exactly one match. Each player played exactly one match against each of the remaining 7 players. When there is a condition given like this, each player plays exactly one match against each other player that is there in the tournament. This is a tournament that we call a league or a round robin. League or round robin. This is where we get to know whether the question is a knockout or round robin, or it doesn't belong to any of these categories. No match ended in a draw or a tie. Excellent. There are no draws. So there are going to be only wins and losses. In each match, 2 out of the 8 players contested and 1 player won, whereas the other player lost. Okay, excellent. Exactly 5 out of the 8 players won 5 matches each. Exactly 5 out of the 8 players won 5 matches each. And there is some additional information that is given. G lost his matches against B, C, D, and E. I don't know where to use it yet, but let us see. F lost his matches against A and but won against G. From the outset, looking at this information, we may be tempted at drawing a matrix where A, B, C, D, E, F, G, H play against A, B, C, D, E, F, G, H, a matrix like this, right? Which will have 64 blocks, something like this. And say that G lost his match against B, but won against C, D, and E. G lost all his matches against B, C, D, and E. Then you will mark whether G won or lost or anything like that. But before you actually go ahead and do that, I suggest please read the entire. When I say please read the entire set, I also mean what are the questions that are following. Do the questions actually require us to find kaun kisse jeeta? Is the question you need to ask yourself, right? At this point in time, it looks like a set that is dependent on forming points table. If you know how to form a points table for this set, you will be very easily able to solve the questions. Let us take a look at the questions. What is the total number of matches played in the tournament? This particular question will not require any additional data. You don't require to form even a points table or a matrix to be able to solve this question. So this question can be easily solved. I'll tell you how many players won exactly one match. Now probably for this you will have to refer to a points table. How many matches were won by A in the tennis tournament? Again, points table will help you. If in the points table A wins 5 matches, A can be winning 5 matches. A wins 1 match, A can be winning 1 match. That's it. But there is an option called cannot be determined. This is where you need to be careful. Probably there are cases. Question 4. How many matches were won by F in the tennis tournament? So how many won by A and how many won by F? So I think at this point in time, we don't need to worry about who exactly won against whom. That is not what the questions are asking. The questions are asking who won how many matches. What is the number of points that these particular persons will have in the points table. So I think you don't need to draw a matrix for this question. You only need to draw a points table for this question. Let's come to the decision making criteria, whether or not to solve this question. Basically, if you look at the setup and there are only 2 additional points. There is a small setup and there are 2 additional points which can be easily read and understood in not more than 2 minutes. Easily within 2 minutes, you can actually assimilate all the points that are given over here. The only question you need to ask yourself when you are looking at this kind of a question, this question requires a particular logic to be cracked. The only question you need to ask yourself is whether I know that logic or not, whether I have the capacity to form the points table based on this information. If you feel you have, you should attempt this question, because once you have the points table in place, it is easy to answer all the 4 questions that are there. But if you do not have the points table, if you do not know how to go about the points table or how the points distribution is going to be, right? If you have no idea about that, even then question 1 is a doable question. In fact, it is a must do question. You read the setup for 2 minutes, you can directly answer the question as 28 and leave the set over there. 28 is the answer to the question. Leave the set over there. You would have spent 3 minutes and got 3 marks out of the set, and it is good enough. Leave the remaining set. That is one way of looking at it. So the decision making criteria essentially depends on whether you know how to go about forming a points table or you don't. How to go about forming a points table is what I am going to discuss. To understand how to go about a points table, I have taken a small example here. Let us say 5 players, A, B, C, D, E, all participate in a round robin tournament. That means each player is going to play 1 game exactly against each other player in the tournament. If a player wins a match, he gets 1 point. If he loses a match, he gets 0 points. First of all, let us look at what is the total number of matches in the tournament. If each player has to play against each other player, let us say A is the first player. A has to play against B, C, D, and E. So A is going to play 4 matches. Similarly, everyone else is going to play 4 matches. By that logic, if there are 5 people, A, B, C, D, and E, each of them is going to play 4 matches. By that logic, you will get 5 into 4, 20 matches. But there is something wrong in this. We are ending up double counting some matches. How? If A is playing against B, C, D, and E, B is also essentially playing against A, C, D, and E. But this game where B plays against A is already also counted under the account of A, when we have said that A is playing against B. So this is double counted. So each of the games like this is going to be double counted. For example, if you look at C and say C will play against B, C, D, and E. C versus B is in the row above. C versus A is in the very first row. That is double counting of these 2 matches, right? So essentially what it looks like is something like this. If A has to play against B, C, D, and E, if A has played against B, B need not play against A again. B has to play the remaining 3 matches. B against C, D, and E. C has already played against A and B. C has to play the remaining 2 matches against D and E. D has already played against B, C, and A. So D only has to play 1 match against E. And E, if you look at it, E is already there 4 times in the tournament already. That means E has completed all his 4 matches. So E need not play against anyone else extra. So essentially it comes like A will play 4 matches. That includes 1 match of B. Hence B will play 3 more. C will play 2 more. And E will play 1 more. That makes the total number of matches 10, which is exactly half of this 20. The reason being, when we are saying 5 into 4, 20 matches are there. 5 into 4, 20 matches are there. When you're saying that, if there are 20 matches like this that you are counting, each match involves 2 players. That means you're double counting that. Hence, you're going to divide it again by 2. So exactly you will get 5 into 4 by 2, 10 matches in this tournament. Right? Some of you who know permutation and combination may also apply this thing that out of 5 teams, you select any 2 teams and there is a game. 5C 2 ways of having a match. That is 5C2 is equal to 10 matches. Right? But it is essentially the summation of 1, 2, 3, 4, so on up to n minus 1. So if there are n teams, the number of matches is going to be 1 plus 2 plus 3, so on up to n minus 1. which is equal to n into n minus 1 by 2, which is also equal to NC2. So the number of matches in a tournament of n teams, if it is a round robin tournament, is going to be NC2, which is also equal to n into n minus 1 by 2. So in this tournament that I have assumed of 5 people, there are going to be 10 matches. And if there are 10 matches, each of the 10 matches will have exactly one winner. That means the total number of points in the tournament should also be equal to 10. 10 matches, 1 point for each of the matches. If the total number of matches is 10, the total number of points also needs to be 10. Once we have decided that, what are the various combinations that add up to 10? For example, A wins 4 matches, B wins 3 matches, C wins 2 matches, D wins 1 match, and E wins 0. This is a summation of 4 plus 3 plus 2 plus 1. The total is 10. The total number of points in the table now are 10. So this is a possible combination. I don't have any issues with this. But how many ways can we get this 10? Could we have had a 2, 2, 2, 2, 2, such that each of the players wins 2 matches each? This was also possible. This was also possible. But can we have a 4, 4, 1, 1, 0? Though this also adds up to 10. Is this case possible? The third case. Is the third case possible? Can the points table look like this? That is exactly what is the logic required for solving that question that was there on the previous screen. Could we have had 4, 4, 1, 1, 0, though the total sum is 10? Is this a possible case? Is this a possible case? For you to better understand that, you don't need to actually look at A ne kisko haraya, B ne kisko haraya, C ne kisko haraya kind of things. What you need to understand is that within the tournament, C, D, and E. Within the tournament, C, D, and E are 3 teams which will play against each other. If these 3 teams, C, D, and E, are playing against each other, there are 3 teams. There are 3 teams. If C, D, and E are playing against each other, there are 3 teams. These 3 teams within themselves should have 3 into 2 by 2, that is 3 matches. If there are 3 matches that only C, D, and E play among each other, if there are 3 matches that C, D, and E play among each other, there have to be exactly 3 points, at least 3 points between C, D, and E. For that, in the first case, you can see that C has 2, D has 1, E has 0. It is okay because 3 matches, 3 points they can have. No issues whatsoever. In the second match, case, you have C and D both having 2. You need at least 3 points. You need at least 3 points, which is not violated. However, in the third case, C has 1 point, D has 1 point, E has 0 point. C, D, and E together have only 2 points. C, D, and E together have only 2 points. That, my friends, will not be possible, because if C, D, and E together are playing a mini tournament within the tournament, they are playing 3 matches against each other. They are playing 3 matches, and there have to be 3 points at least between C, D, and E, which is not the case in case 3. Hence, this case will not be possible. वो लोग आपस में 3 मैच खेल रहे, कम से कम 3 पॉइंट तो दो यार. That is not happening. That is not happening in case 3. Hence, we will not be able to consider case 3. We will not be able to consider case 3. So what we have seen is that any combination of 3 teams taken together, should have at least 3 points in between them. Now, if I concentrate only on the first case, that is 4, 3, 2, 1, 0. A won 4 matches, B won 3 matches, C won 2 matches, D won 1 match, and E won 0 matches. That is only possible if A beats B, C, D, and E, all 4. B beats the remaining 2, 3. C beats the remaining 2, and D beats E. Right? This point distribution will only be possible in this case. Only be possible in this case, that A wins against all 4, B wins against the remaining 3, C wins against D and E, D wins against E. In any of these cases, in this case, can we conclude that C, D, and E among themselves, C will win against D, C will win against E, fine. D will win against E, fine. Right? But C, D, and E will not be able to win any of the games against A and B. Against the top two, C, D, and E will not be able to win any of the games. That is because among C, D, and E, you want minimum 3 points. Because they are playing 3 matches against each other among themselves. You want minimum 3 points. And you can see that there are exactly 3 points. That means these 3 points would have come. These 3 points they would have earned by playing among each other. The smaller tournament between C, D, and E would have earned them 3 points. That means outside this smaller tournament between C, D, and E, when any of these players is competing against the top two teams, against A and B, they have no scope to win. They have absolutely no scope to win. This is the logic that we require to understand, that a certain group of teams has minimum points required between them. A certain group of teams has minimum number of points required between them. Then they have to get their points by playing among themselves. So in this case, for example, we can see that C, D, and E are playing a mini tournament within the tournament. There are 3 matches. They need a minimum of 3 points, and they have exactly the minimum number of points required between them. And you can see that those 3 points they have earned within the tournament, within the mini tournament itself. They could not have earned it against the top 2 teams. That is the reasoning, that is the understanding that we require to be able to solve the set that is ahead of us. Now let us take a look at the actual question that is in front of us. There are 8 teams. I have got a table with 1, 2, 3, 4, 5, 6, 7, 8 teams. I don't know what order they are. I don't know whether they are A, B, C, D, E, F, G, H in that order. But there are 8 teams. 1, 2, 3, 4, 5, 6, 7, 8. Right? We know that exactly 5 out of the 8 players won 5 matches each. Exactly 5 out of the 8 players won 5 matches each. That means 5 into 5. 25 points are gone among the top 5 players. 25 points are gone among the top 5 players. What is the total number of matches going to be here? The total number of matches, there are 8 teams, is going to be n into n minus 1 by 2, 8 into 7 by 2, which is 56 by 2, which is equal to 28, which is equal to 28. That is the answer to the first question, by the way. 28. What is the total number of matches played in the tournament? 28. If the total number of matches played in the tournament is 28, how many points should be there in the points table? Assuming that for winning 1 match, you will get 1 point. If you lose, you get 0. There is no draw or a tie that is possible, right? So there have to be 28 points in the tournament. There have to be exactly 28 points in the tournament. Now we know that the top 5 players have taken 25 points within them. So the top 5 players, each of them have 5, 5, 5, and 5, and 5. Each of them have 5 points each. That means the bottom 3 players taken together, because the total number of points in the table should be 28. The top 5 already have 25. Bottom 3 taken together should have exactly 3 points among them. Exactly 3 points among themselves. And how will they get those 3 points? How will they get those 3 points? The 3 points distribution could have been 1, 1, 1, or it could have been in a form 2, 1, 0. There are some people who may argue with me that why not a 3, 0, 0? See, 7 and 8, team 7 and team 8, both of them are playing 1 match against each other. There has to be at least 1 point within them. Hence, a points table cannot have 2 zeros. Even if it is Royal Challengers Bangalore and Rajasthan Royals, koi to jitega, 1 point to do. That is not available in the case of 3, 0, 0, right? So it is only 2, 1, 0 or 1, 1, 1. That are the 2 arrangements that are possible. Given that the top 5 teams, this is the first case, this is the second case. The top 5 teams will get 5 points each. The bottom 3 teams taken together will have 3 points. So this is the list of bottom 3 for me. And this is the list of top 5 for me. Right? So You could have, after 5 5s, you could have 1-1-1 or 2-1-0 as the points given to the last 3 players. The question is asking how many players won exactly one match. In case 1, there are 3 players who won exactly one match, player 6, player 7, and player 8. In case 2, there is only 1 player who won exactly one match. So there can be either 1 player or 3 players who could have won exactly one match. So either 1 or 3, option D will be the answer to this question. Option D will be the answer to this question. How many matches were won by A in the tournament and how many matches were won by F in the tournament? For this, we need to understand a few more things. Take a look at this. The minimum number of points that should be with players 6, 7, and 8, because there are 3 teams, have to be 3, right? And they have exactly 3 points between them. That means, can I say that these bottom 3 teams, whatever points they received, they would have received by defeating each other only. 6 can beat 7, 7 can beat 8, 8 can beat 6, whatever can happen. But the bottom 3 cannot defeat top 5. Bottom 3 cannot defeat any team in top 5. That is the understanding that is required to be able to solve this question. Right now, let us take a look at the information that is given. G lost his matches against B, C, D, and E. G lost at least 4 matches. G lost at least 4 matches. There is no way G is going to win 5 matches. Can I say the bottom 3 list includes G? G is definitely there in bottom 3. We can say that. F lost his match against A but won against G. F lost his match against A but won against G. Okay, F won against G. F can be in the top 5. F won against G. F can be in the top 5. Or F can be in the bottom 3 also. F lost his match against G. We don't know where F can be as of now. Right? Additional information is given for questions 3 to 4. Right? So we can use the additional information for 3 to 4 also to be able to solve the remaining 2 questions. G has won his match against H. G, who is in bottom 3, has won his match against H. What does it tell about H? G, a bottom 3 team, can only defeat a bottom 3 team. Remember that. So G, if G is defeating H, if G is defeating H, H also has to be in the bottom 3. H also has to be in the bottom 3. H also has to be in the bottom 3. Right? A lost his match against both C and D. Okay, A has lost his match against both C and D. I don't know where to use it as of now, but take a look at the question. The question is asking how many matches were won by A in the tournament. We have to determine whether A belongs to the top 5 group or the bottom 3 group, where we already know that the bottom 3 includes G and H already. Bottom 3 includes G and H already. There is only one more space left in bottom 3. Let us assume that A is in the bottom 3. If A is in the bottom 3 and F lost his game against H, F lost his match against H, F lost his match against A, sorry. If A is in the bottom 3 and F lost his match against A, that means A defeated F. A is in the bottom 3. Who can A defeat? A can only defeat a bottom 3 team. That means F also has to be in bottom 3. But the bottom 3 has only 3 spaces. G and H are already occupying 2 spaces. Could both A and F be accommodated here? No way. So this assumption that A belongs to bottom 3 is false. That means A must belong in the top 5 teams. A must belong in the top 5 teams. A could have lost his game against C and D. He only needs to win 5 matches. He can lose against C and D and win all the remaining 5 matches. No issues with that. A, however, must be in the top 5. That is because if A is in bottom 3, we will also have to accommodate F in bottom 3. So A has to be in the top 5. And if A is in the top 5, he would have won 5 matches. That is something we can definitely determine. How many matches were won by F in the tournament? Question 4 is asking, what about F? F has lost his match against A but won against G. F won against G. F won against G. Okay, F can be in bottom 3. F can win against G. I don't have any issues with that. F can be in bottom 3. F can win against G. I don't have any issues with that. But F lost his match against A. F lost his match against A. If F lost his match against A, F can be in the top 5 also. F can be in the top 5 also. There is no compelling statement. If F had won against A, then in that case, we will have to accommodate both F and A over here. But as of now, F could be accommodated either in the bottom 3 or top 5. There is a possibility that F belongs here and the remaining 5 teams belong in the top 5. Or there is a possibility that F belongs in the top 5 and there are remaining, there is one more team or one more player who is going to come into the bottom 3. There are both possibilities available for F. So F could have won 5 matches, F could have won 2 matches, 1 matches or 0 matches. We don't know. We don't know about that. Even if we could have determined that F belongs to bottom 3, we could not have determined how many matches F would have won. How many matches F would have won cannot be determined. Definitely not 3. No team is going to win 3. He could have won either 1 match or 5 matches or 2 matches. We could not have determined that, however. So this was a set that if you know the logic of cracking a points table, how many minimum points need to exist between a given set of teams is the logic that was required to crack this. If you know that logic, then the set is very, very doable and doable within 6 to 7 minutes, believe me, right? It is a very easy set if you know that logic. If you don't, however, know that logic, don't venture out into such questions. जिसका आपको logic का कोई idea ही नहीं है, don't venture out into such questions in the paper. If you are not able to determine what the logic is in the first 2-3 minutes, don't venture into that. So that's it. That's the set for you. So if you like the content of this video, if you like the solutions and the approach of these questions, please like the video and share with your friends and subscribe to our channel. We'll be coming up with more videos like this more often. Thank you.